over the lunch break if you would like a chat with them. But what I want to do now is separate these two pieces of paper. That would be my dream. Uli Thie is a health and safety rep. He's also technical demonstrator in the 3D design workshop at Massey University School of Design. He's passionate about developing and teaching safe design model making skills. Uli is a health and safety rep on Massey's National Health and Safety Steering Group, and he believes the HSR role isn't something you can do successfully during a lunch break.
That was pretty much my speech.
Oh, is this? What you want to?
You can't steal my speech.
I'm going to stop talking. I'm just going to hand over. He is the winner of the 2021 Rep of the Year at last year's awards. Obviously, Uli joins us to tell us about his journey so far. Give him a massive round of applause, Uli Thie.
Okay. Nice, my first slide. Okay, let's start with the second one. Okay, tēnā koutou, talofa, grüß Gott, and greetings to you. My name is Uli Thie. I am your Health and Safety Rep of the year 2021, and thank you so much for that award evening last year. It was just great, and well, I promised I'd do a speech, and in the time in between I thought maybe I shouldn't have. I'm really nervous, but okay. So my speech is about Jenga, old brooms and user perception, and you will get my very subjective and personal reflections about being a health and safety rep for Massey University. So that is a little bit of a disclaimer there. Massey University, Te Kunenga ki Purihurua, has almost 20,000 students and more than 3,000 employees across 3 campuses in Wellington, Manawatu, Albany, plus a 4th virtual campus that is delivering online education. I am one of the 2 union reps on Massey's National Steering Group for Health and Safety. And I am also one of the 12 health and safety staff reps on the Wellington campus, and we have, as you see in the slide, we have 44 health and safety reps across all campuses. That leaves us 29 reps short to fill all the positions, and Massey has recognized that this is an issue and aims to make the role more attractive. I will come back to that innovation project. And first I want to talk a little bit about my background, so you understand where I'm coming from and how that is related to health and safety. And my job is also crucial. I work on the Wellington campus at the College of Creative Arts. The biggest concrete casting mold that I ever made was for this load-bearing entrance wall of Massey University's Te Ara Hihiko building. And Mohio, Toi, Matoranga, Mana, Whanongatanga, virtuosity, creativity, understanding, autonomy, connectedness. These 10 words, they are literally cast in concrete now, and they describe what our creative graduates should be known for. And I will show you how this educational goal is reflected even in the practical training that we have to offer in the workshop. I'm an industrial product designer, and I work in the 3D design workshop of the School of Design. My job is called a technical demonstrator for design, which is sort of a human Swiss Army knife for teaching, design research, support, coordination, workshop organization, maintenance, and health and safety and first aid. Research support in a design workshop means, for example, working on the industrial design, development of farm equipment for New Zealand's Gallagher company with the legendary Professor Emeritus Dr. Tony Parker. You see him in the picture top left. And about Gallagher, you have heard yesterday already what they're doing. It's a fantastic company. It's great to design with them. Teaching and teaching support in our context means to teach together with leading academic staff everything 3-dimensional in regards of design, and that is model making, idea generation, product development and prototyping, ergonomics and function testing, and all while keeping everything running smoothly and safe, of course. Every one of our 150 staff or 1,500 students of the college who is interested in three-dimensional design can learn how to safely use the 65 machines and processes that we offer in the design workshop. Usually it's roughly half of the staff and half of the students that actually sign up for the workshop, so it's 750 students currently that are signed up for the workshop. The design model making skills that we currently teach are conventional woodwork, furniture joinery, conventional metalwork, turning, milling, welding, sand casting, digital prototyping with resin 3D printing, laser cutting, water jet cutting, CNC milling, spray painting, coating, special effects and material simulation, conventional casting in various materials, sketch modeling in foam and card, and function modeling in mixed media. We have only 3 to 4 staff to do this job, including myself. Given our long list of tasks, it's quite obvious that health and safety is a big part of my job. Over the years, my colleagues and I have designed a whole system of technical education which is filling a gap in the otherwise academically focused university curriculum. We continuously improve our systems and the know-how how to run a modern educational design workshop at a university level, and how to teach and demonstrate the processes to students and learners, and how to train up the new staff into teaching the required skills to others. We share our knowledge with the tertiary education in New Zealand, with secondary school teachers, and for sure also with the other health and safety reps from other universities and also internal. So how does the technical education system basically work? It starts with the workshop induction tours for groups of new users, followed by a digital safety test at the end of the tour. The new learners get workshop access then, and they are allowed to participate in demonstrations. A demonstration is a subsystem of specific machine and process inductions for whole classes or for individual learners, followed by training tasks and individual sign-offs. Let's have a quick look at the safety test. So you have to sit that safety test right after your guided induction tour if you are a new model maker, and using your own phone gives you then a sense of familiarity right from the start. If there are any barriers to accessing the test, then we talk the learners through the questions, and barriers could be that just there's a language problem, some ability problem, stress, or even if they just can't be bothered. So then we talk them through. The multiple choice question that you see there is when must you put on and wear your PPE, and the selected answer, put it on during campus open days only, is obviously wrong, but funny. The correct answer is put on your PPE before entering an area in which a hazard exists, and then you answer out of the 25 questions that you get, you answer 24 right, and then you have a pass. The successful test results are uploaded into our database, and then the students get the swipe card access, like I already said. Before they can use a machine fully, they have to attend the demonstration and perform the training task, then they get signed off for it, and so everyone is learning in baby steps and builds up their model making skills really step by step. We also have our own training videos on YouTube and on Facebook, so if you want to check me out on YouTube, you can learn how to use a craft knife safely. Craft knives are injury number 1, so we take that very serious. And we have all the social medias as well, but you know that stuff. So half of the year, for 26 weeks of the year exactly, we are teaching our undergraduate students, that is highly structured technical teaching about the safe use of machines and how you use that in your academic design project. And during the other 26 weeks of the year, the focus is more on the postgraduate students and the staff research support, maintenance and teaching preparation. The whole workshop is only closed over Christmas and New Year. The range of the students is quite diverse. So we have the undergraduate students who are usually very young and curious, and they come with very little experience. So we have to build up a full model making skill set within the 8 semesters of study. The postgraduate students are often mature students and have quite a varying level of skills and professions. And the research, teaching and support staff are more autonomous, explorative, and are often quite advice resistant, so this is where it can actually get a bit more dangerous also. So being advice resistant is quite a common trait amongst designers and artists. So relying on the existence of common sense in a creative educational workshop could be a very risky assumption in regards to health and safety, because we have that broad variety of people and culture and previous knowledge and skills. So one thing is clear, that common sense per se does not exist. This is something I have to make clear to every new staff that we get in the workshop. Don't come with common sense. Common sense, being on the same rational page, is not a given. It's in fact one of our highest goals is to establish a common sense, to establish a common talk about how things are made and what the background is. To keep our demonstrations and supervision fresh and up to date, we always keep one graduate on for a year to help us with teaching and also with finding the right words to clearly communicate even complex matters for our young audience. And that is actually a task that is not that easy. Could you adequately summarize a whole code of conduct in 4 words so that young people accept the message? Have a look at the t-shirt on the right side of the next slide, designed by one of our leading college staff. The message on the t-shirt is to the point, easy to remember, well designed, funny, age appropriate, and apparently non-offensive. Yeah, a college researcher has researched that, so I just say it like it was told. The use of language is clearly changing, and I think we have to keep up with that. Just imagine how official signage will change and might just look in a few years' time. We try to use a bit of humor and find the right balance to communicate clear rules and firm guidance in a user-adequate and non-patronizing way. This meme about Leonard Nimoy as Mr. Spock definitely leads the way there. The picture is placed on the entrance door to our resin room with all its inherent chemical hazards, and here, don't play with super glue is a great conversation starter. Having a few signs with entertainment value helps to engage the majority of users into actually reading the text. It gets the message across to most of them, but not always. Let's have a look at some more workshop signage. So, what are the problems with workshop signage? Firstly, the visual overload of signage can distract from concentrated work. Second, signage can give a false sense of being able to teach yourself all know-how. Just have a look at that yellow sign that I removed from a bandsaw after someone cut their finger while being distracted by this visual riddle. The funniest thing is that was the old workshop manager. Yeah. So then the next thing is the do not use signs often get ignored. So Massey University added a clear lockout, tagout policy for all broken machines now. And then one more issue is that some users simply do not read signs, really. You can test this hypothesis also in your area if you just put a prank sticker like the one on the picture on the bottom left. If you put that on a machine, just pick whatever you like, and the results are hilarious. Most people will start shouting at the machine because the sticker says voice activated. Some people get the prank right away and laugh, but some don't react at all, even when the sticker is clearly in their field of vision. If that would be workshop signage, then not reading it could have really serious consequences and lead to injuries. So what's going on there? There are 2 possibilities. It could be the wrong language. So text-heavy signage is less effective with our international students who might be not fluent in English. But we found that a bigger amount of those people that don't react are actually just Kiwi students and staff that are not reading the text-heavy signage. And they were not reading it simply because they had difficulties in reading them quickly enough. According to an estimation of one of our college researchers, up to a quarter of students and staff of the College of Creative Arts would have a level of dyslexia or another form of neurodiversity. And this is quite common for creative industries. Since that was all news to me, I went to a conference about the implications of dyslexia for health and safety in the workplace. And if you have a look at the text sample in the top, apparently illustrating what a person with dyslexia would see at first glimpse, so that's quite tricky to read, isn't it? So if how we look at that thing now and we try to read that, if this is in any way comparable to how a dyslexic person would read a safety sign, then it's clear why that doesn't work, why there's a limit on the effectiveness of text signage. To put it differently, if we don't reach up to a quarter of our users efficiently and effectively with a crucial message about safety, then we have to change tack. So university students with dyslexia are often highly intelligent and often have very good coping mechanisms to adapt to environments. They tend to try and fly under the radar to avoid stigma, and they have a different and often slower perception of written text. I can promise you that in your work area there will be someone with dyslexia and you don't know it. So it's really worth getting your head around that stuff. So let's see how a user-centered design could help us. So the first step is to try to understand the users and their needs, abilities, culture, identity, behavior, background, all those human factors. And understanding this complexity is important to design a safe practice that is based on facts and human factors and not on assumptions. Unfortunately, electronic surveys, as much as we like them, won't cut it. Users with dyslexia or any other language difficulties are underrepresented in the survey results simply because they are less likely to participate in the first place. So the survey results will suffer from sampling bias, and this might also explain some hiccups that you have in your systems. Our experience with the phone-based safety test that you saw earlier confirms clearly the limitations of electronic surveys unless the reading is supported by personal interaction. Now, if all that you have is a hammer, then everything looks like a nail. That is just a saying that describes that most people have their one favorite strategy of solving a problem, but when it doesn't work, then you have to really diversify and look for alternative strategies. So what is the advantage of a user-centered design approach over a problem-based design approach in our educational workshop? It's quite clear it is safer, because it allows for the inclusion of users with dyslexia or different language barriers without compromising safety. If you have a look at this picture of our disk sanders, so in the machine demonstration, the new user gets shown by a staff person how to put the workpiece on the safe side. That's the right side of the sender table, where the disk pulls downwards when operating. The red paint works as a visual reminder not to place the workpiece here, else the sanding disk could fling the workpiece up or in the direction of the user and cause harm. To simplify the technical teaching, we simplified all our disk sanders so that all the sanding disks will only spin clockwise when operating. We have found that our color-coded solution works better for our staff and students as a visual reminder of what they have learned in the machine demonstration than the old text-heavy signage that we had previously. So we have replaced a user-centered, a problem-based design solution with a user-centered design approach. Now let's go into that one. So quite some things, health and safety, fit into this classical engineering approach, maybe because most workshops are used and set up by designers, by engineers. The problem-based design approach is linear and goes like this. We identify and analyze a problem and design an intervention to fix it. In a pure engineering context, everyone who is using the intervention stops having the problem, so the problem is solved. This technical simplicity is very efficient and convincing, but there is the risk of oversimplification in regards of human factors. The problem is not solved for everyone. It is only solved for an ideal user who is suspiciously similar to the engineer. The user is designed into the technical process flow by the same engineer who designs the solution, almost as an afterthought. And I've been told that this issue is called the engineer's bias. So the users are peripheral, almost a sideshow. They are just defined as the ones who have that problem, and the risky assumption is that all the users are equally aware of the problem, all have the ability and the will to apply the proposed intervention to fix it. They will not do anything irrational, funny, forgetful, or different stuff either, but actual people like my diverse group of creative users in a design workshop, they would definitely do that. A true user-centered design approach is often an ongoing circular process where we try to understand the user or a diverse group of possible users on a human level before extrapolating a custom-tailored innovation out of the individual context. So the innovations could be new consumer products or new process for a given task, or the relocation of machinery to have a better workflow. The ideal innovation aims at a custom-tailored affordance, allowing a seemingly intuitive and safe application. To get there requires some insight into the human factors of the users, so what influence their thoughts in family, society, culture and work, what is the motivation, the personality, what are the abilities, what are the tasks, actions, behavior, what are known problems, background distractions, what randomly decisions have the users made in the past, what do they do just for fun, and what is exciting for them and what is scary. And then extrapolating from that, what could be a good innovation for those people be? And how would this innovation affect them? Once the user accepts this innovation, their behavior and the inner and outer parameters might change and further innovations might be required. So it's much more complex. Open-minded user analysis fosters inclusion and fairness, is suitable for complex and for high-risk scenarios, and is based on minimizing assumptions about the user. But this analysis might take you quite a while, so to save time, it might be feasible to get some reliable information about a particular scenario from someone in the know. Find an old broom. That old broom could be a friend, it could be a co-worker, a student rep, or the health and safety rep of the department. So you will all know the saying that new brooms sweep well, but the old brooms know where the dirt sits. The old brooms can contribute a lot of detailed insight and help resolve difficult or dangerous situations in the workplace very efficiently. They know the people and they often have an untapped institutional and situational experience and technical know-how that would also be quite useful for proactive health and safety work. This is one of the baselines of the Health and Safety Rep Innovation Project, and we will come back to that. But first, greetings to all the old brooms in this room, so I salute you. Let's wrap up the educational side before we go back to the innovation project. So how do our students or learners, how do they actually see and perceive the world? So do they see and understand everything the way we show it? Let's go to this one. Our workshop training reflects the 5 creative attributes, like I said, of our college that you saw on the slide with the concrete wall panel at the beginning. Creativity, virtuosity, autonomy, understanding and connectedness. For art, the focus is self-expression, virtuosity and autonomy, and the creative focus of a good designer is the user, what they want, require, and most importantly, what they perceive. So how can you train connectedness and understanding of user perception? It's something that we actually all do from an early age. So children play the whisper chain game where all the focus is on the funny ongoing distortion of a message that gets perceived in the end of the chain. So in English, that game is called the Chinese Whisper. I don't know why it's called that, but that's the game. So in the end, there is a different message. The learning outcome is not to take for granted that your message equals the received message in the end, and this is communication theory at its finest. In our special effects classes, our students have to learn material simulation. This is how to quickly paint a model so that it looks like timber, metal, rust, concrete or marble, and commercially that is required for design models that have to be a lookalike, and it's used heavily in the film industry for movie props. To replicate a material appearance efficiently, the students really have to understand that you actually cannot see timber. All you physically can see with your eyes is colors, light and dark, and patterns. That becomes then for the onlooker the information. Timber is something that happens in their brain, not in the eyes. So it's a thought process. So if we quickly fudge up a color pattern onto the model, then the brain of the onlooker will turn that color pattern into the perceived information timber. And designing for that user perception matters a lot, as it turns the designer focus away from yourself and towards understanding and designing for others. Do you know Jenga? So Jenga is a game where you pull out wooden blocks one by one from a stacked block tower. When you get it wrong, then the tower collapses with quite some noise. This game is fun because endorphins and adrenaline give the players the impression of mastering a perceived high-risk activity, while actually nothing bad can happen. Let's call this the Jenga principle. What matters a lot in our busy workshop context is that the emotional response to a Jenga activity supports the remembering of the training content. For one of our workshop Jenga activities, we let the students turn lightweight styrofoam on a wood lathe, and with big discs of materials rotating and big chunks of material flying, nobody gets hurt by this activity, but it gets the adrenaline running high. This Jenga activity gives the students a chance to learn and get basic machining experience. Sometimes they will fail, but then they fail safely. If they fail safely, then they get frustrated, but they will be unharmed. We will not try to avoid frustrating experiences, as frustration can be a motor for learning when we guide the students through it. So overcoming frustration is the best known way to build a realistic confidence in your own abilities. Frustration and excitement are both good door openers for further learning experiences that will be remembered. So we use the Jenga principle to build confidence, curiosity, and memory. And sometimes we simply give the learners an opportunity to show off, if that's their nature. Showing off is not only an age-appropriate behavior for our undergraduate students, but also a quite common personal trait of mature designers and artists. Showing off can be very motivating for some students and can really help them remember a training lesson. But showing off is hardly mentioned in health and safety as far as I know. If you have people in your companies that want to show off and are a problem, find a way how you can let them show off. They can let off their steam and then go back to work. So it's a simple way to work with a lot of young people. It's so important to celebrate every success with our students and colleagues, and it is my job to help to win, that they can win their awards, and I have to support them in any way. The last point I want to make about teaching and learning and health and safety is that in New Zealand everything is much more relational than in any other country I have worked in. It doesn't matter what you know, but who you know. This sentence is a big source of confusion for international students and for new colleagues from overseas. How are we supposed to teach them when it doesn't matter what we know? Why would students learn anything when it won't matter what they know in the end? Isn't that dangerous? I found that teaching and learning in New Zealand is highly relational and trust-based. As experts, we first have to become someone who is known by the learner, and once that relationship exists, the learner will engage with what we know. So whether what we say matters to someone depends initially more on our relationship with them than on our qualification or authority. Once we are trusted and have a voice, then what we say matters a lot. Being a health and safety rep is actually not that different. So that picture shows the staff of the College of Creative Arts, so with the leadership, senior leadership in the front. And yeah, but I want to talk more about the being a rep. So being a TU rep on Massey University Health and Safety Steering Group on the very top of the organization is a fascinating volunteer role. Over the years, I have read a lot of highly complex draft policies and procedures and cooperated with the union and a wide range of enthusiastic colleagues like the Health and Safety Director and his professional team. To provide an example, in the steering group, we had to get our heads around the drafted Massey vaccination requirement policy to battle the threat of the Delta variant. I felt that what I said as rep on behalf of thousands of employees was respected and that my suggestions were valued by the university's top leadership. I do not know how many health and safety reps in New Zealand could say that. I even was, as a health and safety rep, invited into the recruitment interview panel for some of our health and safety positions at Massey by the new health and safety director again. Being also a small department health and safety rep at the very, very bottom of that big university pyramid, I'm really in a good position to compare and reflect the dynamics. The traditional image of being a campus health and safety rep is still a problem. You know, health and safety reps are like smoke alarms. You have to have them, but you don't want to hear them. Once a year, you have to check if they're still there. As I mentioned earlier, Massey is working on turning that image around, also because more than 1/3 of the health and safety rep positions across the Massey campuses are vacant. Positive spin, 2/3 are almost filled. But why actually? After all, it is unpaid extra work to be a rep. You have to read and listen to all that gory stuff that has happened. And being a health and safety rep has the reputation to turn your career into a lead balloon. So why become a rep? For our Wellington group of health and safety reps, one big motivator is collegiality. In collaboration with the awesome campus health and safety advisors, the role of the rep was over the years continually expanded from bare reporting of accidents and facility issues like slip and trip hazards to a broader thinking and discussion about our place in the education system of the university, about collegial support and about our role in backing up others in accident prevention without fear even when there is resistance. As a next progressive step, the Massey Health and Safety Rep Innovation Project was initiated by Joshua Dorman, who nominated me for this award last year. He co-created a pilot program together with reps and line managers to make the role of the rep more meaningful and to attract new and fresh volunteers, but maybe also some more old brooms. To achieve this, we had to really find ways how to make the role more attractive, and when there is not more money available also, then it gets a bit difficult. But in the end, a full presence of departmental health and safety reps in capital investment decisions was proposed as a motivational game changer. This would be a win-win. First, there would be a full health and safety representation of all areas of the university, as every department would want and support a valued colleague as their department health and safety rep on the investment panel. And on the other hand, a real grassroots health and safety perspective would enable well-grounded investment decisions so there are no further bad surprises for management and staff. Like I mentioned, the baseline of the innovation project to integrate all the enthusiasm and unused health and safety expertise that we already have within our employees into a coordinated group of valued health and safety reps who are proactive in accident prevention and risk management. Well, that was my speech about Jenga, old brooms and user perception. I hope I kept you a bit entertained and that you could see how everything in my current work life is connected to health and safety and design and research and teaching and learning. It's all a little bit woven together. I'm really grateful for your work as the actual professionals in health and safety, because that's really important for the country, but it's quite underestimated and it's usually hidden in the background. And so I think it's really awesome that Safeguard improving the public perception of health and safety with events like this conference and the awards. Thank you, everyone, and I'm over time already, so if you have questions, please just ask me on LinkedIn. I'm easy to find. I have such a weird name, so you will find it very easy. And just flick questions through. If there's anything where you think I could help you, I'm happy to do that. Thank you.
That was a fantastic presentation, Uli. We're really grateful to you for sharing your story and your wisdom, and a celebration of old brooms and show-offs is something I'm totally up for. Another round of applause for Uli Thie. Thank you. It was great. Fantastic. Yeah, you're allowed to sit down. You're allowed to go to lunch, but not yet. No one's allowed to go to lunch yet, not until I say